Hello, my name is Kostas and I work as the technical artist teacher at the Game Assembly in Malmö, Sweden. This video is a part of a larger series of videos called Getting Started with ShaderFX for Maya, and in this video I'll be showing you how to do a position-based random variation shader. So what I have in front of me is just a test object I created, and what I want to show in this video is this type of functionality. Now what this is actually the position of the object in the world, or in the Maya scene in this case, driving some kind of random variation. In this case, it's changing what color it's going to tint the upper part of this object with. And for this demonstration, I'm going to look at this already created shader and just reverse engineer it or go through every step. So I won't be necessarily placing all of these nodes, but rather go through every step and explain what's happening along the way. And the intention of this, or the use case, is if you imagine that you're creating a game and you're going to be placing a lot of assets in the game, and some assets might be placed a lot of times, and they might be placed several objects within one frame or one view. You can see several instances of the same object. You might author a shader which actually has some type of built-in functionality to give variation to the object, and you could drive this based on the position of the object in the world. So you kind of get that variation for free, if you will. So the level artist who might be placing these in the game would only have to worry about duplicating them and moving them like this, and you get that variation for free. And if that level artist was not happy with the gray color here and wanted something different, they would only need to nudge the object just a little bit to drive that variation. And the distance you need to move it to get this variation, you can also alter that. So if you think this nudge is a bit too big to get that variation, you can scale that down to have it changing with a much lower threshold of movement. But if I were to say just duplicate a few of these just to show you, so let's just do this, and then I grab these and I duplicate them. So let's make a bunch of copies. Then let's grab these, duplicate them once more, like so. You can start to see that it's kind of like a noise pattern, and it's also the same kind of colors repeating. That's not a coincidence. I'll get into this in a sec, but this is driven from this texture here within Photoshop here actually. So this is like an array of colors, if you will, which represents the colors you just saw in Maya when I was tiling this. So you could imagine this being color variations that your art director or the artist in question had chosen, that yes, I want these colors to appear in different variations of this object. And another cool feature of doing it like a texture like this is that the length or the width of this segment actually works as a distribution amount, or I'm not sure of the correct terminology, but there's a higher probability of spawning a light gray variation of this object than a yellow one, because this is much wider in this spectrum. But at the heart of what's driving this is actually a noise function. So I'll go ahead and just show you. I'll break the shader momentarily just to showcase how this noise works. So I'll go through each step here, but before I focus on that, I want to show you the noise in question. So here's that noise, and currently the way it's applied, it's kind of got, not sure how to phrase this correctly, but like infinite resolution. So it's now being fed by the UVs of this plane, and since the decimal parts of the UVs can probably go into really high precision or go into the really smaller parts of the decimals, you keep getting more and more random variation as it stands right now. But the way I've done it for the variation of my boxes or test asset here is I actually make sure I can set the scale of the random coordinate system, if you will. So instead I'm grabbing the UVs, I'm multiplying by a given scale value that I can set, and then I floor the value. and the floor is the essential part, since it will just it'll round it down to the nearest integer, which means that it throws away the decimal parts, if you will. It would be similar to converting to an integer. So if I apply this type of logic and I've got an exposed scale value, I should now be able to change this scale value. You can even see the difference here. With a scale value of 50, I should be getting 50 different samples in this direction and 50 here. If I were to set it to 4, I would get a 4 by 4 pattern. Now, the way this is applied to the objects then is that I set the scale value which works well enough, and this is actually the same kind of distance threshold I spoke about, where you move it this amount of distance would equal this distance to get that color variation. And so far I've been using UVs, as I mentioned, to drive this. So if I were to move it around, it would follow the object these same colors, since the UV doesn't change as I move it in the world. But if you instead were to feed, say, the position, the vertex position in the world, it would be relative to the world, and as I were to move it around, these would float around, and this gray swatch would always stay in this place in the world, regardless of how I move this. This swatch would seem to be stuck in the same relative position to the world. And to take that even further, I have no need on these objects to have multiple blocks like this, or squares. So what I do for these objects is I actually grab the object position, that is the same transform value you have here. So that's one value for the entire object, regardless of how big or small or what shape it has. But the key thing is, for the other copy of the object, like this one, you're going to get a different value, and that will equate to getting different noise lookup values for all the objects here. So if I were to showcase that, it would see, we should be able to remove this now. It was only for demonstration purposes, but if I were to grab this noise over here instead, which is driven by object position, I would get this type of value, regardless of, as mentioned, the size of this object, since it only relates to these values, which remain unchanged regardless of the scale or size. And the noise value I get is a value between 0.0 to 1.0. And you could then use that random value to drive some form of change. But I'll go back to what I had before, and I'll step through this shader graph or shader network all the way through. So to get object position, you need to use the object position world. And if you place the object position, the world input is a required pin. So if I make sure I'm in advanced mode and I search for object position, this is interesting. I've never seen this yellow frame before. I discovered something new. Oh yes, right, I missed the advanced mode. Here we go. So object position, yes, and you see that this one has a red outline on the input pin, which indicates that it's a required pin for this to function. And then you just search for the node called world. That's one of the different matrices available. So also just grab the world, and if you drag from this, you see that it's the 4x4, which is the required data type. So from this, you should now get the object's position, which is the same you see in the channel box, the object's translate values. Now you will have some issues if you use this node in your network and you have the default viewport 2.0 settings. So I'll need to go in here and see if I can find that in here. Yep. By default, if I were to set the default values, you have Consolidate World enabled. And if you have Consolidate World, you'll get weird glitches when using the object display. You will object position. You will momentarily see the object position functioning correctly as you move an object like this, but as soon as you change the camera afterwards or deselect it or whatnot, it'll jump to a black value. So if you're going to use this node in any network, make sure to uncheck this one. So that is viewport 2.0 settings, disable Consolidate World. Alright, so at this point I'm getting object position, and to drive the random functionality I only want the X and Z position at least in my case. It could vary in your case, of course, but I'm only interested in the placement in this direction and this direction to drive the noise. And the noise in question, which I'm using, wants a two-dimensional input. So if I was stuck at using this noise, I would have to opt for only two directions, or somehow transform three directions into two values to feed the noise function. So I'm grabbing X and Z. I have the same kind of logic I just showed you, where I want to be able to set the scale of the noise, or the frequency, or whatever you want to call it. And I do that with an exposed scale value. I multiply the positional value, and then I floor it, which is rounding down to the nearest integer or nearest whole number, throwing away the decimal part. Then I use this node, which I haven't introduced in any of the videos before. The custom code node allows you to actually type shader code directly in this otherwise node-based interface, such as HLSL. I think it actually supports GLSL as well. Yes. So you have by default, if you create one of these, you get this type of information. So create the node, hit the edit button, and this is your editor window where you can input your shader code. There's some useful notes up here from the authors on how you could use this and what type of shader language is available and such. And then you have this custom code output shader struct, and that shader struct is later used down here to create a variable, or I'm not sure what the correct terminology is here, but a shader struct of this type called out. And then for the out has a component, that's the correct term, according to the struct, which is called color and is a float 4. So here we're setting the out.color with a float 4 value. And here we're just returning the result of that out, or the result of this function, which returns the out. Also notice that this function takes an input as well, which is input A, and that input is then being used here. But the thing is, if you're familiar with typing HLS or you prefer doing it, this could be really useful for you. And other cases where I would argue this can be useful is if you find code snippets that you want to use. So for instance, the 2D noise I'm using here is this one. And I found it on Patricio Gonzalez Vivo's GitHub repository. I'm not sure if he's the original author. I found the same kind of noise function on several other sites, but this is where I got it from. And as you can see, this one takes this is GLSL, so this is equivalent to the float2 value in ShaderFX or HLSL. But it takes a float2 value, which is referred to as n here. This is where I feed my position. The x and z position is fed into here, into the n variable. And then that n variable is then used in a series of various math operations, basically. So there's like there's a multiplication, there's a dot operation, there's a sinus operation, and then there's a fract, meaning it will only keep the decimal part of whatever number this equates to. And then that is returned. But it's simply a matter of copying, pasting this, and then pasting it into this window and formatting it in, making it work with this struct. I've never actually tried. I've only just assumed that I needed to change this into HLSL code, but it should be able to use the GLSL standard as well, according to what it says up here. But the way I would make this work is basically, the first thing I'd realize is that the output from this function is going to be a float output. So I could change the struct up here to say float instead. And I could just rename this one to noise. So now the struct is going to have one component, one data type called a float, which is called noise. I'll then have to remember to change this one here to say noise instead. And on this side, I'm going to output the result of this function. So I could basically just grab this equation here and input this over here. And then the next step is in this one takes a vec2 input, or equivalent to float2, called n, and then n is being used here. So I could, for instance, copy n from here, or just input a, but let's try n. and make sure that I type float2 here. So the input for this function, which should show up as a pin here, is a float2 called n, and then n is going to be used in this equation here. So I think this, just by doing this, I should now have a custom code node which allows me to generate this noise. As soon as I close this window, you should see this update, and see now you have a float2 input called n and a noise output. That's basically what I've done down here as well. I think the difference is I've called this one input and this one is n. But it's a nice way of being able to either, if you prefer typing HLSL, but just copy a pre-existing code snippets to achieve different things. So this is where the noise is being generated from here. And then just to showcase two different means of using this value, I actually opted for, and I'll show you. The first one here is that I grab this 0, 1 value that I get from here, and I let that drive the U lookup. So I'm constructing a 2D vector, which is being used as UV. So I think I've got, this shouldn't actually matter, but I've got the Y or the V component of the lookup at halfway. And then the U value, this one, the X, is being driven by that 0, 1 value. And that maps into this texture map lookup, which then looks in this texture. So the V is fixed at halfway, but as I said, it shouldn't really matter where I sample on V. And then the 0, 1 value from that noise function is going to equate to 0.0 here and 1.0 here. So depending on what value gets created or spawned from the noise function, it's going to sample in different parts of the texture. And therefore, as you understand, since I make a wider representation of this gray, any value which happens to fall inside here would get that light gray. And the yellow one would be a lesser amount if I just spawn enough objects. Yeah, a lesser probability. And I also make sure that if I want these specific colors, you need to make sure that you don't have semi-transparent pixels or some kind of smoothing or blending in between here to make that work. And actually also on the node here itself, I ran into this issue myself and realized why, but by default, if I grab a texture map and we have a look inside, so notice that this is referenced to the texture map on disk, and I've actually removed the reference by selecting this and hitting make group unique to allow me to change the inner workings of this node. But two things you want to change on this node, or actually one thing would be the only required thing. And sadly, let's see. Oh, actually it is. My bad. I didn't actually notice that this was exposed outwards. I was convinced that this was not available from outside of the node. So I should actually be good with using the referenced one. But the thing I wanted to get to is you need to change the texture filtering. By default, it uses this linear type of texture filtering. And what that basically means is, depending on the zoom of your camera, how close or far you are from the texture, it's going to, when it tries to make a representation of the texture, it's going to filter, which means that as it tries to sample around this area, it might get an average value of all the neighbors here. And that means I'm going to get both some of the gray influence and some of the white influence. So I might end up with, I know the issue I found was that I had found both instances which were dark yellow and bright yellow. So some instances were true to this color and some were darker. And I realized that, oh wait, that's because it's sampling near the very edge. And then with the default wrap setting for the texture, anytime that it tries to sample outside of here, it's just going to get the same repeated texture. So it's going to get some of the black influence here. And then due to the texture filtering when sampling near here, and it needs to ask its neighboring pixels, it's going to sample some of that black influence as well, which means I got a darker version of the yellow. So you would get that by default if you try to create this. But if you instead set the filtering to point, it's only ever going to sample one pixel. So you're never going to get that thing of where it tries to ask its neighbors for their color. So if you use this type of lookup texture, make sure you set this one to point. You could set these to clamp as well, but it shouldn't actually matter. It's not a problem that it actually wraps and repeats the texture as long as you don't use texture filtering. Right. What else? So that is the method I've shown you so far. Let's see. Managed to hit the hotkey to isolate. There we go. So this is what you're seeing here. And another thing I tried with the shader, just to show you another idea you could do, is instead of, I've added a setting called color variation method, and we're now looking at the tint array texture. There's also one called hue shift, which does exactly what it sounds like. So imagine having the HSV filter here, or hue saturation filter in Photoshop, and then just shifting the hue value like this. So depending on what noise value is spawned, it's going to shift this one a various amount, or a varying amount of distance here. And I then, in this equation, my original texture, if you've not noticed, I do have, just to showcase that I can have an underlying texture, I've got this type of texture, which is actually grayscale as far as I remember. Yes, I have this grayscale texture as my base texture. And in my HSV solution, I set this is actually my HSV value I'm composing here. So I have HSV, and I've hard coded the saturation part to be, let's see, I'm adding, oh no, sorry, yeah, I set an initial color, which is this color. I convert it to HSV, and then I add this amount to hue. So this is where the random value comes, adds to the hue component, and then that is added to the existing hue value. So it'll just shift the value. And then I'm converting it back into RGB. So that's why we're getting all of these colorful variations instead. And I mean, this could be your desired result. The point is that this type of random value you get from here, you could use it to drive whatever. You could, with the HSV nodes or custom code nodes, you could, for instance, shift the value a bit. Maybe not by much, but maybe you want to retain the same color, kind of coloring you have initially, but you just want to make some darker or brighter copies of the same type of mesh, just to change, yeah, the brightness, if you will. Then you could focus on shifting the value component, for instance. Or maybe, I don't know, you slightly shift the tiling amount of your base set of textures, for instance, or whatever you can think of, like offsetting some type of effect, or offsetting the time of an animation, for instance. So if you have several objects with a cool vertex shader animation which is looping, if they all follow the exact same timing, it's going to really strike you as them being synchronized in your game. And maybe you want to offset the timeline for each of them. Then you could perhaps drive that offset using this noise solution. And just to mention as well, here's another example of where I've used the custom code node. So by default, as far as I'm aware, ShaderFX does not have any RGB to HSV and HSV to RGB conversion. But there's several solutions available on the internet that you could find code snippets for. So in my example, it looks something like this. And this was similar to how I did the noise. It's pretty much just copying, pasting, and making sure I have the correct struct to support the output I want, and also making sure that I sync the input here, so that is the input being used inside of the function. So in this case, I search for efficient. I think I searched for efficient RGB to HSV conversion. I found this solution, which I guess is the author of the LOL engine, and also some contributions from Emil Persson to get to this fast branchless solution. But it seems to work fine. So I think that's pretty much it. This is just loading the base texture and tiling that amount. So we've done that before. All right, I'm using vertex color as well. So just to showcase that for this variation, you might not want the entire object to get a varied result. So I used a vertex color channel to in the red channel, I set these values in the area that gets affected. I set those to 1.0, and the values below here are 0.0. So that way I can mask out which area gets the variation. So that's what I'm doing here. I've got a vertex color node that has an string value node which contains the name of the vertex color set that gets fed into here. And then I hand painted or hand authored the areas that get this mask on the object itself. Then I read from the red channel. And since I'm using an if-else basic to choose which of the paths, if it gets the variation or not, I need to make sure that the thing driving the condition, the on off or true false, needs to be of the data type bool. So I need to convert my vertex color set here to bool. So I float to bool node. The actual color tint in this case is nothing fancy. It's just grabbing this grayscale texture and then multiplying by the color variation method I'm using from this end here. There are other ways of course, color tinting that you could use, but this is just an example to demonstrate some type of cases you could use this for. I'm using a path direction list node as well to be able to change up the different methods here. So I've showcased that in a different video as well. And it's a cool way to be able to change fundamental functionality of your shader in other means than the attributes, but as an actual setting here. So that should be it. Yep. I hope you found this useful. Thanks a lot.